Welcome to the lecture for section 13.2, and this is MGF 1106, Liberal Arts and Math, and my name is Jorge Young. So the objective for section 13.2 is the following. We're going to understand the relationship between the probability of an event and the probability of its complement. Then we're going to calculate the probability of the union of two events, and then lastly we're going to use complement and union formulas to compute the probability of an event. So the first thing we're going to talk about is computing the probability of a complement of an event. And if you remember from section 13.1, we said that if we added up all the probability of all the events in the sample space, it has to add up to 1. So let's say there are only two possibilities. Let's go back to the iPhone. So defective or not defective. So if we know the probability that it is not defective, then we can calculate the probability that it is defective simply by subtracting that from 1. So if E is an event, then P of E prime is equal to 1 minus the probability of E. So here we have the sample space. So E prime has a probability of 1 minus the probability of E. And then of course E just has the probability of E. And if we do the probability of E plus the probability of the complement, that adds up to 1. So how can we use that information to solve a problem? So here the graph shows party affiliation of a group of voters. So if we randomly select a person from this group, what is the probability that the person has a party affiliation? So here we can see that we have about 6 different categories, right? Democratic, Republican, Green, Libertarian, Other, and None. So the easiest way to calculate this is actually to use the complement of party affiliation, which is no party affiliation. And there we can see that so A prime does not have a party affiliation, A has a party affiliation. So let A be the event that the person we select has some party affiliation. So it's simple to calculate the probability of A prime since 23.7% have no party affiliation. So 1 minus 0.237 gives us 0.763 or 76.3% that the likelihood that a person chosen randomly from this group has some party affiliation. So the next thing is the rule for computing the probability of a union of two events. So if E and F are events, then P of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Now, if E and F have no outcomes in common, they're called mutually exclusive events. In this case, the probability of E and F is actually 0. And so the preceding formula simplifies to simply just the sum of the probability of the two events, E and F. So, if we select a single card from a standard 52 card deck, what is the probability that we draw either a heart or a face card? So the first thing is let H be the event, draw a heart, and let F be the event, draw a face card. So we're looking for the probability of H or F. So here we have a diagram. Now there are 13 hearts, 12 face cards, and 3 cards that are both hearts and face cards. So remember, the probability of H or F is the probability of H plus the probability of F minus the probability of H and F. So the probability of heart is 13 over 52. The probability of a face card is 12 over 52. Then from that we have to subtract the probability of heart that is a face card, and that's 3 over 52. And the reason we do that is because if we don't, we'll double count. So then the answer then would be 11 over 26. Now, if you're given any of the 4 quantities in the following formula, then we can use algebra to solve for the other ones. So here's another example. A survey found that 35% of a group of people were concerned with improving their cardiovascular fitness. 55% wanted to lose weight. Also, 70% are concerned with either improving their cardiovascular fitness or losing weight. So if a person is randomly selected from the group, what is the probability that the person is concerned with both improving cardiovascular fitness and losing weight? So let C be the event that the person wants to improve cardiovascular fitness. Let W be the event that the person wishes to lose weight. So then we need to find P of C and W. Now we have that the P of C is 0.35, P of W is 0.55, and then P of C or W is 0.7. So using the formula, we plug in all of these values. So we see that it's going to be 0.7 is equal to 0.35 plus 0.55 minus the probability of C and W, which we don't know what it is yet. We'll go ahead and just kind of switch them around, and then we just add and subtract, and we get 0.2. So the probability that someone wants to improve their cardiovascular fitness and lose weight is 20%. Now, survey of consumers shows the amount of time they spend shopping on the internet per month compared to their annual income. So if we select a consumer randomly, what is the probability that the consumer neither shops on the internet or 10 or more hours per month, nor has an annual income above 60,000? So here we have the table. So here 10 plus hours is the N of T N A, which is 192. N of T is 480. Then N of A, which is income above, is 496. And in the total, the sample space is N of S. So let T be the event. The consumer selected spends 10 or more hours per month shopping on the internet. And then let A be the event the consumer selected has an annual income above 60,000. You can see that on the table. Now, from the table, we get that N of T is 192 plus 160 plus 128, which is 480. N of A is 496. N of S is 1600. So now we may compute the probabilities below. So P of T is equal to N of T divided by N of S, which is 0.3. So that's P of T. Now, P of A is N of A divided by N of S, which is 0.31. Now, P of T N A is the N of T N A divided by N of S, which is 192 over 1600, which is 0.2. So now, the probability of T or A prime is 1 minus the probability of T or A, which is equal to 1 minus the formula, so P of T plus P of A minus P of T and A, and that when we work out all the values, we get 0.51. I suggest you go back, look at the slides on this one, and then go back and follow step by step and how we calculated and came up with 0.51 or 51%. And that's the end of section 13.2. Thank you.